Okay. There we go. Okay, whoops, no flash photography. My name's David Chalmers. I'm a philosopher at the Australian National University and New York University. I'm a Singularity amateur. This is my first time talking about this stuff. But it's a really, and I don't know that I've got that much that's really new to say, but it's a really fascinating and important topic, I think. So I'm going to try and just offer some speculation, some sketchy thoughts from the point of view of a philosopher who's trying to get straight on these issues. I know the singularity means many different things to different people. For me, the key idea is the idea of the intelligence explosion that goes back to a classic paper by I.J. Good in 1965. He really had the idea right there. Let an ultra-intelligent machine be defined as a machine that can far surpass all the intellectual activities of any one man, however clever. Since the design of machines is one of those intellectual activities, an ultra-intelligent machine could design even better machines. There would then unquestionably be an intelligence explosion, and the intelligence of man would be left far behind. Thus, the first ultra-intelligent machine is the last invention that man need ever make. Now, there are a couple of problems here, even aside from the non-inclusive language. You notice that he's actually given us a mechanism from getting from something that far surpasses us to something that far surpasses us. But I think he can clean it up a little bit. So I'll introduce a little bit of terminology that I find handy. AI is just intelligence of human level or greater. AI plus is intelligence of greater than human level. AI plus plus is intelligence of far greater than human level. Superintelligence, if you like. Then you can see Good, if you like, is offering us a philosophical argument, which I'll put here in the form of premises and conclusion, as we philosophers like to do. Premise one, there will be AI plus. Second, if there is AI plus, there will, soon after, be AI plus plus. So conclusion, there will be AI plus plus. This is an argument for the possibility of superintelligence, and the two premises are meant to be plausible. Now, I think maybe it's worth unpacking this argument a bit further. So here I've put it in the form of one with three premises and a conclusion, and a bit more qualification in there. I mean, the first two premises here can be seen, if you like, as providing an argument for the first premise of the previous version. There will be AI plus. We'll break it down into two steps. Premise one, there will be AI. And then we'll add we'll add a temporal element, because I think that is commonly regarded as part of the singularity framework, and we'll add a qualification. Temporal element before long. I'll say more about what that means. Absent defeaters means absent certain things that might get in the way. More about that in a second, but roughly, disasters, active prevention. So, premise two, if there is AI, there's going to be AI plus, relatively soon after, absent defeaters. Premise three, if there's AI plus, there's going to be AI plus plus, superintelligence, soon after, absent defeaters. And that, of course, is the core of the Good argument. Conclusion, there will be AI plus plus, there will be superintelligence, before too long, absent defeaters. Okay, so there's an argument for a strong conclusion. And I think you can make a decent case for all the premises. First, a bit about the qualifications, the time frame, and the defeaters. What does before long mean here? Well, for some people, it's within decades. I'm going to go conservative here, within centuries. Maybe that's too conservative. Maybe it's pessimistic. I do think that a lot of the dates we hear thrown around are a bit on the optimistic side, 2030, 35, 2040. I think, we all know that the bottleneck in AI is not the hardware, it's the software, it's the algorithms. And what we've learned from the history of AI is that bottleneck. The software problem is just a much, much harder problem than you might have thought it might be. I don't personally see the evidence that they were that much closer to solving the software bottleneck than we were 20 years ago, with all respect to everyone who's here. But still, we're just quibbling over, we're quibbling over decades here. 2035, 2075, 2135. The philosophical issues are much the same. Soon after, on the other hand, that I think we can say means something of the order of within years. Within minutes, within seconds, within years, within decades, within years. Once you've got AI, you can expect to get to AI plus soon. Once you've got AI plus, by the good reason, you can expect to get to AI plus plus very soon. And the defeaters here, well, we could make a list of them, but disasters, earthquake, thermonuclear war, interplanetary catastrophe, or active prevention, unless there's a really serious effort to prevent this from happening, and that could happen. Who knows how effective it would be. Okay, so now we've got the three premises, 1, 2, 3, and 4. Let's just look briefly at the case for each of them, because if you accept the premises, it looks like you pretty well got to accept the conclusion. Well, premise 3 is the I.J. Good point. Assume we create an AI plus, then an AI plus will be better than us at AI creation. Therefore, it'll be able to create a greater AI than we can. Well, the one that we can create is itself. So it'll be able to create an AI greater than itself. Repeat until superintelligence. Repeat until AI plus plus. I think that's the core of the intelligence explosion, and pretty hard to argue with. Premise 2. From AI to AI plus. Well, here are the thought. There's different thoughts here. Assume we've created an AI. And let me now here add a rider. Assume we've created an AI by an extendable method, by a kind of method that comes in sort of parameters and degrees that we can push forward in certain ways. Then we'll inevitably soon improve the method and create an AI plus. Now note, for this argument to work, this requires an extendable method. I mean, we have a method of creating intelligence already, right? It's biological reproduction. Is that leading to AI plus? No. Why not? Because it's not, as it stands, a directly extendable method. It's not like if we just reproduce better, have sex really well, then our kids are going to be geniuses that exceed us in these ways. So biological reproduction is not an extendable method in the relevant way. Nor, I think, interestingly, nor obviously is brain emulation, which people talked about this morning. It's not as if we emulate brains really well, then we're going to end up with superintelligence either. I mean, maybe brain emulation is in some ways a speed up for a singularity. Once we emulate brains, we can run them faster, get a whole lot more of them, and do things which will then result in the creation of AI plus happening sooner. But I do think we need a separate mechanism. I mean, maybe coming to understand the brain and to work to extend the mechanisms. Brain emulation could play a role, but that's one reason for some hesitancy about brain emulation as the key to a singularity. You need an extendable method. Premise 1, the path to AI. Why I believe there's going to be AI? Well, the basic obvious answer is, well, evolution got here, and furthermore, it looks like evolution did not need a whole lot of intelligence to get here. Evolution got here dumbly. Here we are, we're at least dumb, and maybe we have the advantage of a little bit of intelligence. You'd think that somehow we could get here too. Okay, hopefully we're going to do it a bit quicker than evolution, but we know there are dumb ways to get to intelligence. Surely we can find them without too much intelligence. Now, okay, one big issue in analyzing this argument is this question of intelligence, which is appealed to as an unanalyzed notion. Now, of course, intelligence is not a unitary thing. There's many, many different measures you could have, and it's not clear they're all measuring the same thing. Now, I don't know, I'm sure people here have thought about this a lot. It strikes me that the concept of intelligence is really not essential to the structure of the argument at all. All you need is certain kinds of mathematical structure. I mean, let's say that a parameter, G, tracks capacity A if increasing G, bigger G, tends to increase A, tends to improve the capacity. Now let's say that a self-amplifying parameter, G is self-amplifying if G tracks the capacity to create systems with G. Presumably there's reason to think there are such self-amplifying parameters. I mean, good takes it that intelligence is one of them, but it's presumably there are quite a few of these. I mean, you can define more delimited notions that will still do the job, but that's the rough kind of parameter we need. And then let's just say that G is an intelligence measure in some broad sense. If G tracks certain cognitive capacities, A, B, and C, we can come up with a big list if you like. Learning, playing chess, speaking languages. On you go. The list doesn't matter for the structure of the argument. Then we've just got to put forward some kind of thesis. So we'll call it the Generality Thesis. There's a self-amplifying intelligence measure. That is, some parameter G, such that increasing G, or probably better, increasing G from a certain baseline, tends to increase the capacity to create systems with G, and tends to increase cognitive capacities, A, B, and C. So really we need two things. G, the self-amplifying measure, the measure such that increasing it tends to increase the capacity for G, and a correlation between G and these further cognitive capacities, because G in its own right may not be all that interesting. The thought is it might correlate with things like learning, memory, language, which we are interested in. Then we can substitute G for intelligence in the previous arguments. We don't need to make a reference to intelligence. And it looks like if you accept then premise one, if you accept then the premise that we can create systems with better G than our own G, that's AI plus, it just follows then that you'll get to exploding G, and it follows that you're going to get exploding capacities, A, B, C, and so on. I mean, it depends on the strength of the correlation, but you can see the rough structure here. So all you need is self-amplifying measure, the right kind of correlations, you'll get explosion in the relevant capacities. Now, somebody might actually want to argue with the generality thesis and hold that, for example, the ability to program AI is absolutely independent of all these other features like, happiness, language, learning, memory, and therefore the explosion is not going to apply to any other cognitive capacities. I find that, I think you can make a pretty good case against that, but there is a substantive thesis here. Okay, so this then raises the question, we've got this abstract question of paths to AI and then to AI++. How are we going to get to AI? Well, few choices here. Number one is direct programming, program the intelligence directly. It's what they started doing back in the 50s, kept doing through the 70s. Turned out to be really, really hard. Maybe some people are still trying to do that now. I think that may require, that direct creation of intelligence may just require way more intelligence of us than other methods. Brain emulation is a really interesting possibility. It's got the problem of not being extendable. I also suspect it's going to, given the limits of neuroscience, it's going to take a bit longer than people think, but that's an open question. Learning from a developmental basis, I think, is obviously very promising, but turns out to be a very, very hard problem. My own money, and this is just something I'll say without argument, is on evolutionary methods, simulated evolution or evolutionary computation. It's how we got here. We know that you can get to intelligence by dumb methods from an unintelligent start. If we figure out a couple of the tricks, then good reason to think that we might be able to replicate that. So that's where my money is. Furthermore, the intelligence explosion argument as put forward by I.J. Good turns on the first premise that says we start with humans creating human plus intelligence, and things explode. But if you look at the structure of the argument, really, it doesn't need that. All you need is some system S that can create or lead to S plus intelligence by some, and then if you've got the self-amplifying property of the parameter, then off you go. Even if S is actually much dumber than us, if you start from self-improvement at a level much lower than ours, nevertheless, intelligence will explode. So I think that provides a useful way to think about evolution here. I mean, usually, you'd think that we're probably somewhere around the bottom limit of systems that can create systems smarter than themselves. I mean, dogs and apes are not terribly good at it, at least by the programming AI method. But you can think of evolution as a biological method for systems to lead systems smarter than themselves. If S is dumber than us, S can't directly create S plus intelligence. But S can still yield S plus intelligence through evolution. So simulated evolution is in effect then a dumb path to super intelligence. So my own prediction is that, being the relatively dumb creatures we are, we need a path to super intelligence that is as dumb as possible. And this may be the dumbest way to get there. So that's a big plus. Now, it turns out, nevertheless, getting open-ended, powerful, simulated evolution right is a very hard, unsolved problem. My own bet, nevertheless, is that it's an easier problem than getting things like learning right, let alone getting intelligence right directly. Nature did it, after all, from very few resources at the beginning of the day. I mean, it's hard to make it open-ended, hard to make it powerful, but that's my bet. Taking that as a premise, if we arrive at AI plus, greater than human intelligence, through simulated evolution, it seems very likely that it's going to take place in a simulated world, not in a robot or another system directly interacting with our environment. That's just going to be a very, very slow process for evolution to happen with this kind of direct interaction and reproduction and so on. My bet is on the much faster process of it all taking place in a virtual environment, simulatedly. If that's the case, then what follows, practically and philosophically? In the remainder of the talk, I'm first going to address practical questions about negotiating the singularity and philosophical questions about our place within the singularity, in the place of consciousness and identity. So first, negotiating the singularity. I take it the question really that's driving many people here and in the Singularity Institute. So the question really is, how can we negotiate the singularity to maximize the chances of a valuable post-singularity world, that is, a world that sort of accords with certain important, or that you might think of as a broad moral question, to make the singularity world as good a world, post-singularity world, as good a world as possible. There's also a selfish question about our place within it, and that of our descendants, which I think is quite legitimate to ask. Maximize the chances of a valuable post-singularity life for ourselves and our descendants. So how do we do this? Well, I think ways for doing this divide up a couple of ways. First of all, we can try to put certain kinds of advanced constraints onto the AI systems that we're developing, and that's something that people here have thought about, in particular trying to get the values of artificial intelligence systems right, so that they'll be friendly, so they'll cooperate with us, so that they'll be benign. And I'm all in favor of that project. Still, I think we should, be fully aware that especially if we take evolutionary routes and other routes, what happens here may well be unpredictable. So I think we should look at other mechanisms as well to maximize the chances. The other kind of method is the possibility of ongoing control of AI, the development of AI, AI plus, so we can see what's happening as it goes along and make certain decisions about whether to continue. And that raises a bunch of interesting questions. I think, the only way in which that's really realistic, ongoing control, is in a simulated world, which is another point in favor of simulated worlds. AI plus, or AI plus, I don't know about AI plus plus, but AI plus in a simulated world, certainly AI in a simulated world, offers us somewhat more control. So we're not inhabiting the same environment as the AI or the AI plus. We can at least make initial observations about the AI and the AI plus and decide how to proceed compared to, say, a robotic situation where here we are, we're in a common environment, we're interacting, there's no kinds of mutual sealage, and so on. So there's the possibility of initial observations. Now, I take it getting it right is still a very tricky question. You might call this the ideal, if you like. It may be impossible, but the ideal is the leak-proof singularity, we can call it. So we'll have a leak-proof simulated world constructed so that the laws of the simulation do not allow systems in the simulation to leak out into our world. That is, at least simply by the evolution of the simulation itself. That is to say, unlike in the Matrix, there are no red pills. I mean, boy, that's a dumb way to design a simulation if you ever saw one, that actually gives people this possibility not just to find out about the Matrix with glitches and to get out. I guess maybe the architect had his reasons. But from our perspective, no red pills. So without red pills, then okay, the AI Plus doesn't immediately leak out simply by following the internal rules of the simulation. Now, of course, that's not good enough. I mean, a fully leak-proof singularity, that is with no leakage whatsoever, is either impossible or pointless. I mean, I take it for a singularity to have a point. For us, it's got to be observed, right? It's got to make some difference to us. A non-pointless singularity can be observed. When we observe, information leaks out. That's the nature of observation. So we look at the simulation, it affects us. Okay. Now, leakage, at this point, of course, leakage of systems in a singularity is under our control. This is a point that Anna made this morning, that people in this community have talked about. If we're communicating with a superintelligence, they will very soon leak out. They'll very soon convince us to let them out. Look at all the wonderful things that we can do for you. Someone's going to let them out. I take that basically for granted. They're going to get out. So if they have information about us, likewise. Okay, so I think the key then to at least temporarily leak-proof singularity, the key to a controllable singularity, it seems to me, is not so much to prevent information from leaking out, although that's important, but to prevent information from leaking in. The moment they have information about us, they'll know about us, they'll be able to interact with us and communicate with us, and then the game's over, if you like. So closed systems without ongoing input from us, with input at the very least minimized, possibly to zero. Now, of course, there's still the question of design of the simulated world. Even the design of the world will provide hints for an AI++. So I take it that design quirk should probably be minimized. We don't want those superintelligences to be making those arguments from. I guess this is a place where what do you call it? The intelligent design movement might take over. So maybe it'll be the dumb design movement. It's like, boy, our gods are these idiots, and now this is how we can manipulate them. So I don't know. I think quantum mechanics is. I don't know. I think our creators, if there are any, we're pretty smart to come up with that. So anyway, so some maxims for the leak-proof singularity. Just to summarize, so create your AI in simulated worlds, no red pills, no external input. That's really important. And fourth, I haven't stressed this so far, but just go slow. You've got one great advantage of a simulated world is you've got a kind of control over it that you don't. I mean, I presume there's going to be flags at every stage, right? In the responsible simulated evolution of AI, for example. Once you get to AI, it's a flag. Okay, temporary stoppage. It's like those bells on Wall Street, right? The trading mechanism. And things, when weird stuff starts to happen. Go slow. Okay, look at the next step, look at the next step. Once we get to AI+, slow down. Again, this gives us the possibility of observation and decision. If an AI or AI+ simulated world is not benign, then we can try again. I mean, of course, there's all kinds of ethical questions that arise now. Can you just pull the plug on a whole simulated world? Or maybe that's mass murder. On the other hand, I think there's nothing stopping us just, slowing down the clock speed to a very deliberate pace, so those guys still get to be continuing their same old subjective experience in their world. Well, in the meantime, we work rapidly over here on our new simulated singularity, and hopefully, hopefully things go better the next time. If it's benign, we can then attempt integration in a controlled way. I mean, I don't say this is a panacea. I don't say that we're not going to encounter any problems this way. It does strike me as the way to go if we want to maximize the chances of a benign singularity. Okay, but this then gets to the question of integration into a post-singularity world. How do we integrate ourselves with a post-singularity simulated world? I mean, in a post-singularity world, I take it, there's going to be AI++. there's going to be intelligence that's a whole lot greater than our own. I take it we don't want to be left behind. Okay, so how do we integrate? Well, I take it really the only legitimate possibility here is some form of uploading of our cognitive basis into some kind of system that has a chance of operating on the same timescales as the superintelligences, and then some form of self-enhancement. I mean, what are the alternatives? I guess we can choose to live entirely separate lives in our own separate little bits of the world, or separate virtual worlds where we're operating with our slow brains in our nice little fantasy worlds. I don't find that terribly appealing. I mean, I think if there's superintelligence around, boy, I want to be part of that. I think a lot of us would want to be part of that. Living as cohabiting as inferiors, which I think is even worse, and of course extinction. So I think integration is the most attractive of these by far. I think that just raises. I mean, our brains are going to be horrendously slow machines, but compared to the machines that these post-singularity systems are running on, they're also going to be, and also even independent of speed, I take it, the cognitive capacity is going to be way behind. So upload and self-enhance is really the only way to go. This then raises, okay, all kinds of questions for a philosopher of mind. I take it this is why people here invited me to speak, so I've written some stuff on consciousness. Question one, will an uploaded system be conscious? I mean, uploading is really going to suck if, once you upload yourself, you're a zombie. And two, will it be me? You might say, okay, it's not a whole lot better if it ends up being conscious, but somebody else entirely, nice for them, not so great for me. So those are the two big questions, consciousness and identity. I mean, those are all enormous questions in their own right. Just to say something about consciousness, look, I don't think we have a clue how a computational system could be conscious. We're really pretty well in the dark on that. But look, we also don't have a clue how a brain could be conscious. I mean, that's the hard problem of consciousness. If someone tells you that they've figured that out, they're kidding themselves. There's a very serious problem here. Still, I don't think computers and brains are in different situations here. There's no reason that I can see for a lack of parity between brains, between wetware and dryware, if you like. No difference in principle between neurons and silicon. I think there are arguments for parity. Here's one very quick route to an argument for parity. Think about gradual uploading. Uploading one neuron at a time, preserving organization throughout the process. Then will so I stay conscious, at least at the beginning, throughout the process. Will consciousness fade, or will it disappear? Well, there's really three options. It'll gradually fade, it'll wink out at a certain point, or it'll stay constant. No time to go into all this now. I've written something about this in the paper cited here. My view is that the fading option and the disappearing option there are good reasons for finding them very implausible. By far the most plausible option, to which we should assign at least the highest credence, is that consciousness will stay constant. So gradual uploading, I think, there's very good reasons to believe it'll preserve consciousness. And by the way, I think once this actually happens, once there is gradual uploading, this is what's going to convince everyone to do it. Your friends are going to be uploading, they're going to be saying, yep, so far so good. So far so good. I mean, they're going to be functional equivalents. They're going to be computational behavioral equivalents. They're going to be saying all that stuff. So far so good, so far so good. So if it has faded or disappeared, we'll never know. We'll all end up doing it and turning into zombies. But I think very good reason to believe that consciousness will be preserved. So consciousness then, one way to put this is that consciousness is an organizational invariant. Systems with the same pattern of causal organization have the same sort of consciousness. It's an invariant because same organization, you preserve the property. So replicate the fine-grained causal organization, you replicate the consciousness. If so, systems in a simulation can be conscious. Because what's beautiful about computational simulation is that it does seem to replicate matters of fine-grained causal organization. By the way, if you think that quantum processes are important here, that's fine. I think all these arguments go through just fine with quantum computation as opposed to classical computation. So that's where you get to from organizational invariance. Just as a bit of an incidental note here, I've actually argued that much in some other papers, in some other stuff, especially this paper on the profound topic of the matrix, I've I've argued that much of reality can be seen as a kind of organizational invariant. That is, duplicate the organization of reality, you duplicate much of what matters. So people raise this question by asking, what if we're in a simulation? What if this has been a matrix all along? And hey, it might be. I can't rule it out. Well, the official ideology of, say, the movie and of most philosophers have thought about this is, if so, the world is an illusion. There are no tables, there are no bodies, all these relationships are kind of fake, and so on. I think that my own view is, if we're in a simulation, there are still tables, there are still bodies, there are still relationships. It's just that the world has a very different kind of computational metaphysics to it. It's tables and bits and so on. Tables, bodies, atoms, and so on have a computational level underlying them, much as, Stephen Wolfram and some people think about actual physics. That reconfigures our metaphysics of the world. It doesn't overturn our belief in reality. If that's right, simulation will preserve much of what's important to us, which I think is an important question when it comes to assessing the value of our potential post-singularity lives. The other question, then, is the question of personal identity, which I think is a hard and confusing question. Will an uploaded system be me? Now, unfortunately, personal identity seems not to be an organizational invariant. You could have a twin of mine right next to me, right here. Maybe my twin and I would have exactly the same kind of consciousness in some sense. Consciousness is an organizational invariant, but my twin is not me. It's a different person. You kill my twin, then, okay, I'm not happy about that. But I'm happier about that than about the prospect of your killing me. Those things are very different. You're wrong. I have 5 minutes. I say I started at 3:35, which means this is 30 minutes?
10-minute Q&A?
Yeah. Okay, so 3 views. 3 views on the personal identity question. Any 2 systems with the same organization are the same person. That's implausible because of the twin question. Okay, now here's a much stronger view. To be the same person, that requires exactly the same matter. That's implausible because of neuron replacement. Our matter changes over all the time, so there's got to be something in between. To be the same person over time requires some kind of causal connectedness and maybe some kind of organizational relation. But what sort? And that's one of the hardest questions in philosophy. Well, I think the best kind of causal connection that guarantees, that's got the best chance of guaranteeing the presence of personal identity or survival is continuity of consciousness. So again, gradual uploading is the way to go, neuron by neuron, staying conscious throughout. Then you've got one stream of consciousness throughout. I think a continuing stream of consciousness throughout is the best guarantee of something like survival. Maybe that's comparable to ordinary survival. On the other hand, maybe that's not going to be possible. Maybe the singularity is not going to happen within my lifetime. Probably not, is my bet. I'm probably just going to miss it. Damn. So if I'm dead, and if my brain is unrevivable, then gradual uploading is impossible. So this leaves the possibility of reconstructive uploading, from records. Maybe my brain's still around. If my brain's not still around, maybe brain scans are still around. If our brain scans aren't still around, maybe there's audio still around. Maybe there's video still around. Is anyone filming this? Books, papers, and so on. And AI++, a super intelligence. They're going to be really good at reverse engineering. Hopefully an AI++ could reconstruct my causal organization from this. From enough of this, they can do the work. The question, will the reconstructed system then be like me? Well, again, there's a lot of debate about this. The pessimistic view is, well, great, that's about as good as my twin surviving. I mean, better than nothing, but it doesn't mean that I survive. Optimistic view is, it'll be like my waking up in the morning, that I'll still be around. I actually favor a view which is, in some ways, a combination of these 2 views. I mean, at least I have some sympathy towards this view. I don't know the right answer. Let's call it the Buddhist view. That ordinary surviving, every day, waking up every day, is like my twin surviving. In a way, each waking is really like a new dawn for something that's a bit like the commencement of a new person. But it turns out That's good enough. That's what ordinary survival is. We've lived with it for a long time. It's good enough. If that's so, then reconstructive uploading will also be good enough. And that's roughly my view here. So then that just leaves us with a practical question to conclude. How can we encourage superintelligence to reconstruct us? Well, write articles, give talks about the singularity. Why the hell do you think I'm here? Let's just hope they're as self-absorbed as we are. That's the end. Thank you. Okay, we got a bit of time for questions. Maybe some debate as to just how much time, but yeah.
Your logic that AI plus will lead to AI plus plus.
Okay, I'll go back to that one.
I think that assumes that creating AI plus is an intelligent decision by us. It might be a lack of intelligence, and the AI plus will not have that lack.
Oh, I see. I see.
Don't want to create AI plus plus.
So what you get out of this is that an AI plus will have the capacity to create a better one. Then I'll have to add to my list of defeaters. Okay, here is a defeater. I mentioned active prevention as a defeater. Maybe once they're smarter than us, they'll have the capacity to create something smarter than them. They will not act on it because, hey, they've got the insight into seeing that that's the end of them. Look, if so, I count that I put that under the category of defeaters. Yeah.
So, of course, I have a number of comments on that talk and have to now carefully select from the various ones. But in the case of trying to simulate evolution without us intervening, that's going to take extremely large amounts of computing power and possibly, I mean, if you're not intervening, which was one of your guidelines for that box,
yeah.
You're going to need an amount of computing power comparable to the creation of all the biological organisms in the history of time on Earth. And conversely, and evolution is just sort of no one intervening. It's the default case of intelligent design with intelligence equal to 0, is the way I sometimes put it. Intelligently designing an AI is hard, okay. Sometimes we need to do hard things, because another thing with evolution is you're not going to be able to control the values, and if you're not exerting any sort of shaping influence over the values, you're going to have to do an awful lot of restarts before you end up with something just like human values. And
Yeah. Well, okay, it's important to note that when I said simulated evolution, I didn't mean necessarily simulating biological evolution the way that it happened on Earth with all of its false starts. I mean, there are a lot of different evolutionary algorithms out there, and there are genetic algorithms, there's genetic programming, there's their successors. I'm taking it that evolutionary algorithms of that kind, with a bit of intelligence going into their design, could offer us a very big speed up on the kind of evolution we actually got on Earth. Yeah, if we have to simulate the whole universe from the Big Bang onwards, then we're probably going to have to wait a couple more decades for that kind of evolution to happen. But yeah, I mean, there is an issue there. Yeah.
So you might imagine this superintelligence would be a rather marketable product. So if you imagine venture capitalists funding a group to do your evolved intelligence design, how long do you think they would wait once they had an apparently viable product before they went through your long, careful process to make sure it was all right, or do you think they just ship it?
I'm thinking the military. I'm thinking the military has a pretty strong interest by this point, and despite the might of venture capitalists, there's going to be some. There may well be some pretty serious.
All right. How long will the generals wait before they ship it?
I see, for use as a weapon. Look, I think this is going to be a serious debate, which hopefully at some point enters the political process. Not just a military process, but the political process. I mean, hopefully we do a bit of a better job with it than we've done with other issues that concern the future of the planet. But I think that conferences like this are important. Look, myself, I don't think it's a 20-year issue. I think more it's closer to a 50 to 100-year issue. But it gradually has to become part of the political process so that we can actually have this argument, and the generals, the politicians will be influenced by what goes on within the public process. So you're right. So there have to be some controls on the military, and that's only going to come from, I think, discussions within the public sphere. Yeah.
Right. Well, I certainly like the idea of trying to contain the process to avoid an immediate Terminator scenario. But it seems to be inherently problematic, and I think you've actually sort of addressed this in your talk, in that even though we would try to make the best black box so that they can't tell that we're there or observing them or whatever, assuming that A plus does occur, they might be able to perceive that in ways that we don't even know how.
So you think a training process via social interaction, that's where your money is?
Well, we have huge numbers of, huge amounts of silicon interacting with humans every day, every time somebody clicks.
Yeah, look where it's gotten us so far. I don't yet see the route to superintelligence. If someone combines this with an amazing learning algorithm, then great. I mean, the question really is, so traditional learning algorithms or evolutionary algorithms? And it really is an empirical question, which is going to get us there. Okay, last one, I'm told.
All right. My question is actually related to that. I'm wondering what you would draw as a dividing line between a learning algorithm and an evolutionary algorithm, because it seems to me somewhat that learning is an evolutionary process of thought.
Yeah, I guess I'm thinking roughly as intergenerational processes versus inter-lifetime processes versus within-lifetime processes. And I'm thinking we get places through an interaction between learning within a lifetime and evolution across lifetimes, which of course is how it worked for us. And I think there's pretty good reason to think that combination of within-lifetime learning with cross-lifetime evolution, for example, to optimize learning methods, to lead to better and better learning algorithms, which is something I wrote a paper on years ago, I think it's that combination that's particularly powerful, perhaps more powerful than learning algorithms alone or evolution alone. Now, you can turn around and redescribe that as a multi-level learning algorithm, if you like. I mean, I don't mind how you use the language, but I think it's that particular kind of interaction that may well be part of the key to potential success of evolutionary methods. But yeah, it's a huge question. Okay, well, thank you very much.